Welcome back to the session on the course Wave Optics. Okay, this session is about the lasers and holography. The last unit is about the lasers, what is spontaneous emission, stimulated emission, and we are going to see the types of lasers, that is solid state laser and one gaseous state laser, and then we are going to see about the holography. Okay. Myself Prakash, working as a lecturer in Department of Physics, K.B.N College. Without wasting much time, let us get into the session. In this session, we are going to see about the introduction to the lasers. What is the acronym? What are the characteristics of lasers? And then we are going to see what is absorption of radiation, or we can say stimulated absorption. Then what is spontaneous emission, stimulated emission. Then we are going to see population inversion, what are metastable state, what is the lifetime of metastable states. Then we are going to see about the main principle that is involved, which is, we can call it as the laser principle. Then we are going to see Ruby laser, how it is constructed, how the working of the Ruby laser. Then we are going to see about the helium neon laser, its construction, its working, how the stimulated emission is achieved. Then we are going to see about the applications of lasers, where the lasers are used in day-to-day lives. Then we are going to see about the holography, how a hologram is created, how it can be captured. Then the applications of holography. Okay. And today's first topic is about the laser. What does the laser mean? What is the acronym of laser? What is the abbreviation, we can say? What is a laser? They said laser is a light amplification by stimulated emission of radiation. L stands for light, A stands for amplification, S stands for stimulated, E stands for emission, and R stands for radiation. In a total, the acronym of laser is light amplification by stimulated emission of radiation. Actually, laser is a device which emits a powerful monochromatic beam. It will emit only a monochromatic beam of light, and the nature of the monochromatic, we know that it is coherent in nature. Okay. The main principle involved in the laser is the stimulated emission. That's why here the acronym, in the acronym itself, it is there. It is the stimulated emission of radiation. Light will be amplified by using the phenomena of stimulated emission. Okay. Laser means light amplification by stimulated emission of radiation, and it is a monochromatic, it is a device which emits the monochromatic beam of light. Okay. Then what are the characteristics? What makes the laser different from the other lights, or we can say what makes the laser different from the ordinary light? First one is it is highly directional, or you can say high directionality. It is one of the characteristics that will make the laser different from the ordinary light. Why? Because ordinary light spreads in all directions and its angular spread is 1 m by m. But it is found that laser is highly directional as compared to the ordinary light, and its angular spread will also be less compared to that of the ordinary lights. For example, the laser beam can be focused for a very long distance. It can be focused for a very long distance within a few divergence or angular spread. But by using an ordinary light, we can't achieve that. Here you can see, by using ordinary light, the angular spread is more. But coming to the laser light, its angular spread is less. Okay, it is one of the characteristics of laser. Then coming to the second characteristics, it is highly intentional. The laser light is highly intentional. Why? Because an ordinary light spreads in all directions. The intensity reaching the target, or you can say the intensity reaching the screen, will be very less. But in case of laser, it is different. Due to the high directionality, as I said, due to the high directionality, the intensity of the laser beam which is reaching the target is of high intensity. Why? Because its angular spread is also less. This is one of the characteristics that make the laser different from the ordinary light. For example, 1 milliwatt of power of helium laser appears to be brighter than that of the sunlight. Just 1 milliwatt power of helium neon laser light appears more brighter than that of the ordinary sunlight. This is the reason why it is high intensity. It is one of the characteristics of laser. Now, coming to the third characteristics, as I said in the acronym itself, it is highly monochromatic. It will be having only single wavelength. Single wavelength. Laser beam is high monochromatic. Why? Because the wavelength is single, whereas in ordinary light, as you know that the ordinary light is nothing but a white light, it will be divided into 7 colors, or dispersion of light. It will be having many wavelengths. That's why the laser light is monochromatic, whereas the ordinary light is polychromatic, you can say. Now coming to the last characteristics, the main characteristics of laser is high coherent. What does it coherent means? Two waves which are having same phase, same path difference, then you can say that the two waves are in coherence. The two waves are in coherence. It is important to characteristics of laser beam is that high coherence. In lasers, the wave trains having same frequency are in phase. The direction gives out in mutual agreement, not only in phase but also in direction. You can see here the coherent laser beam. Due to the high coherence, it results in an extremely high power. But coming to the incoherent LED, it spreads in all directions and it is not in coherent manner. This is the main characteristics of laser beam. These are the 4 characteristics that are responsible, or you can say that are inbuilt in a laser, that makes the laser different from the ordinary light. Now coming to the second topic about the spontaneous absorption, or you can say absorption of radiation. What does it mean? What is the phenomena? How it can be achieved? You can see in this topic. The process, here you can see the process of atom transfer from the normal state corresponding, which will be having minimum energy, to the higher energy state is termed as excitation, or you can say in this thing E1 is called as the normal state and E2 is called as the excited state or higher energy state. E1 will be having less energy as compared to that of the E2. In this process, the absorption of energy from the external field takes place. Suppose an atom present in the energy level E1, whenever an external energy falls on that atom, it will goes to the excited state E2 by absorbing a frequency of h mu. The atom in the ground state, as I said, the atom in the ground state will be goes to the excited state E2 by absorbing a frequency of h mu. This process is known as the stimulated absorption or absorption of radiation. The atom will goes from the normal state or ground state to the excited state by absorbing a frequency is known as the absorption. The time duration for which a particle to be exist in an excited state is nearly equal to that of 10 power minus 8 seconds. This is a lifetime. It will be called as the lifetime. The lifetime is about 10 power minus 8 seconds. On the other hand, the particle can remain in the excited state for a limited amount of time. It will be only in a limited amount of time. Suppose if the lifetime cross about 10 power minus 8 seconds, it will comes again to the ground state or the normal state. This will be termed as the lifetime of a particle or lifetime of an atom. Now coming to the next one, which is about the spontaneous emission. in absorption we have seen that the atom, by absorbing some frequency, it goes to the excited state. It will goes to the excited state. Suppose h mu is the frequency that is falling on the atom which is present in the ground state. It is absorbing E2 minus E1 by h. That is the frequency for which it is required to go to the excited state. Now coming to the second one about the spontaneous emission. Now the atom is present in the excited state which is represented by the energy level E2. Now the excited state is not stable, as I said. It will be having some lifetime period. After completion of lifetime, it will again comes back to the ground state. After a short interval of time, the atom jumps back to the ground state by emitting a photon of frequency mu, as mu is the frequency which is absorbed by it when it is present in the ground state, and it goes to the higher energy state E2. The same amount of frequency is emitted by the photon, is emitted by the atom while coming to the ground state. Okay, here you can see it is the same energy which is absorbed by it, it is emitting. This type of emission is known as the spontaneous emission. The emission of radiation from higher energy state to the lower energy state without any external influence. Here no external field is acting on it. It is happening by its own. After completing its lifetime, it is coming back to the ground state by emitting the same amount of frequency which was absorbed by it. This phenomena is known as the spontaneous emission. Okay, this phenomena is known as spontaneous emission. Then the main important emission topic, stimulated emission. What does it mean? Which is the principle that is required for the lasing action? Stimulated emission, as the acronym itself consists, light amplification by stimulated emission of radiation. What does it mean? We'll see here. As I said that what the spontaneous emission means, the atom will comes back to the ground state by emitting the same amount of frequency which was absorbed by it initially while going to the excited state. Now this process the spontaneous emission happens without any external influence. Note these points. The spontaneous emission happens without any external influence. Now we know that the average lifetime of an atom which is present in the excited state is about the 10 power minus 8 seconds. Now the atom comes back to the lower energy state emitting an additional photon. In this process, listen, see, in this process the atom comes back to the ground state by emitting another photon or additional photon which will be having the same frequency. This process is known as the stimulated emission, but this happens in the presence of an external influence. Here you can see in the before stimulated emission diagram, the atom which is present in the excited state, when the atom present in the excited state and another photon is hitting it. Okay, another photon or another external field or another external light falling on this atom which is responsible for the atom to comes back to the ground state. Now the atom will, while coming to the ground state, it will be emitting another photon or additional photon which will be having the same frequency. This phenomena, this process of forced emission caused by the incident photon is called as the stimulated emission. The main difference between the spontaneous emission and stimulated emission is that while in spontaneous emission no external influence takes place, no incident photon will hit the atom present in the excited state, but coming to the stimulated emission, when an atom present in an excited state, it will be influenced by an external photon which is responsible for it to comes back to the ground state by emitting another photon which will be having the same frequency of it. This process is termed as the stimulated emission. This process is termed as the stimulated emission. Now we are going to see what are the differences between the spontaneous emission and stimulated emission. What are the differences between the spontaneous as well as the stimulated? Then coming to the what are the differences between spontaneous emission and stimulated emission. To see the main differences between spontaneous and stimulated emission is that the emission of photon takes place immediately during the transition of an atom from the ground state to the higher energy state. But coming to the stimulated emission, the emission of radiation takes place by an induced photon, by an external photon. It is responsible for which the atoms comes back to the ground state. The emission of spontaneous emission will be having a broad spectrum, but coming to the stimulated emission, it is monochromatic and it will be having only single wavelength. That's why it is responsible for the lasing action. Now the spontaneous emission is incoherent radiation, while as the stimulated radiation is having monochromatic light, it will be in coherent nature. Coming to the stimulated emission, it is less intense as spontaneous emission is less intense as compared to that of the stimulated emission. That's why it is high intense. Stimulated emission is high intense, and the directionality is also less. The directionality is less for the spontaneous emission as well as the angular spread. But coming to the directionality of the stimulated emission is more as compared to that of the spontaneous emission. The angular spread is also be less. Okay, for spontaneous emission, the example is light from a sodium or mercury vapor lamp. But coming to the stimulated emission, light from a laser source. No, let us get in. See this diagram, the pictorial representation of spontaneous and stimulated emission. You see the atoms which are present in the excited state will comes to the ground state by emitting the photons. But coming to the stimulated emission, whenever the external photon hits that atom, it comes to the ground state. But here you can see initially there are only 2 photons, but after completion of the stimulated emission they are becoming 4. Why? Because an additional photon is emitted in the stimulated emission. Here there are 2 atoms, no, that's why 2 additional photons are emitted. This is how the spontaneous and stimulated emission occurs. Now coming to the other topic, population inversion. What does the population inversion mean? The process by which the population of an particular higher energy state is made more than that of the specified lower energy state is known as the population inversion. Here you can see in this diagram, initially in this diagram, as in general, the lower energy state or the normal energy state will be having the more number of photons, more number of atoms as compared to that of the higher energy state. But by using some method known as pumping, we will achieve the population inversion. What does the population inversion means? The number of atoms that are present in the higher energy state will be made more than that of the number of atoms present in the ground state. This phenomena is termed as the population inversion. The process in which the population inversion can be achieved is known as the pumping. Pumping is the method in order to which population inversion can be achieved. A system in which population inversion is achieved is known as the active system. The system where this population inversion can be achieved is known as the active system. Now coming to the process as I said, the process of achieving the population inversion is known as the pumping of atoms. There are 4 types of pumping mechanisms that are available. Okay, the first one is the optical pumping, which will be used in Ruby laser. The second one is the electric discharge method, which is used in helium neon laser. And the next one is direct conversion. It will be a direct conversion which will be used in semiconductor lasers. And the last one is the chemical reaction, which will be used in CO2 lasers. Okay, different pumping methods are used in different lasers. As I said, lasers are divided into different categories like solid state laser, gas laser, dye lasers, liquid lasers, semiconductor lasers. Based on the type of lasers, the pumping mechanism will be chosen. Okay, these are the 4 types: optical pumping, electric discharge, direct conversion, and chemical reaction. Then what are metastable states? Okay, In general, as I said, that an excited atom will stay in the excited state for a lifetime of nearly 10 power minus 7 or 10 power minus 8 seconds. But even if you apply some energy continuously to the atoms to transfer them to the ground state, even to the excited state E2, they immediately comes down to the ground state. In this way, population inversion cannot be achieved. Okay, if an atom goes to the excited state after completing lifetime, it is coming to the again ground state, means how we can achieve population inversion. But in order to achieve the population inversion, which is responsible for the pumping action, okay, which is responsible for the stimulated emission, we must have an energy state which will be having more long lifetime as compared to that of the excited state. Such an energy state is termed as the metastable state. Okay, the state which will be having more lifetime as compared to that of the excited state is termed as the metastable state. In general, the lifetime of metastable state will be 10 power minus 3 seconds. Okay, it will be of 10 power minus 3 seconds. Now, next topic, it is about the principle of laser, or you can say laser principle. What are the steps involved in achieving the laser principle? The 3 steps we are going to see. The basic requirement to the lasing action is that there must be more atoms that will be present in the metastable state than the ground state. It is an important point. Note this one. The metastable state should always have more atoms compared to that of the ground state, in which the population inversion is achieved. In which population inversion of metastable state should be greater than the population of the ground state. In this way, we can achieve the population inversion. The first step involved in the laser principle is the pumping action. Okay, pumping action. In this diagram, you can see initially the atoms will be present in the ground level or the normal state, which is having energy of E0. The energy of E0 will be less than E1, less than E2. Okay, the energies of E0 will be less than E1, E1 will be less than E2. Now, as I said, the atoms will be present in the ground state. By using the pumping mechanism, the atoms will be pumped to the excited state E2. Okay, it will absorb a frequency of E2 minus E0. Okay, this method can be achieved, this process can be achieved, can be done by the phenomena of pumping. Now the atoms will be present in the excited state E2. Now the atom will after completing certain lifetime, they comes back to the E1 state, which will be termed as metastable state, or you can say that after going back to the excited state, after completing its lifetime, the atom will comes back to the metastable state by emitting a spontaneous emission. As you know that the spontaneous emission can be possible without any external influence, and photon will be emitted here. Then photon will be emitted here. Now the atoms will coming and being there in the metastable state, so that the number of atoms present in the E1, which is a metastable state, increases compared to that of the atoms that are present in the E0. Now, as I said that after collisions, the atoms will comes to the E1 state with emitting a photon, or there may be a energyless or no transition takes place. Here no photons will be emitted. It depends upon the laser. But after coming to the metastable state, the atoms will comes to the ground state by emitting a photon. That photon will be there in the active medium, while hitting the two mirrors will hit the atom that are present in the metastable state. When that atom hits the other atom which is present in the metastable state, as you know that the stimulated emission means the process of achieving of emitting two photons, and it takes place in the presence of an external influence. That initial photon will be acted as an external influence and it will hit the atom present in the metastable state. Then that atom will comes to the ground state by emitting two photons. In this way we can achieve the stimulated emission. This is a process how we can achieve the stimulated emission. Now coming to the first laser, first solid state laser, which was invented by Myman in the year so called 1960, which is a Ruby laser. Coming to the introduction of Ruby laser is a 3 energy level solid state laser. It will be consisting of 3 energy levels and it was constructed by the scientist Myman in the year 1960. Actually, the Ruby laser will be consisting as a ruby rod, which will be in pink color, which is made up of aluminum oxide and chromium oxide, and is a crystal of aluminum oxide in which 0.05% of the aluminum are replaced by the chromium ions. The aluminum ions are replaced by the chromium ions, and the color of the rod will be in pink. The active medium of the Ruby laser is chromium ions. The chromium ions are responsible for the lasing action. Now these are the introduction. Now coming to the construction. The construction of Ruby laser will be having mainly of 3 parts. First one is called as the active working material, second one is resonant cavity, and the third one is the exciting system. First one is active working material. What the active working material means, the Ruby crystal will be having an active medium of Ruby crystal, which is of length 4 centimeters and 5 millimeter in diameter. It will be of 4 centimeters in its length and 5 millimeters in its diameter. It is a place where the population inversion is achieved. Active medium or active material is the place the population inversion is achieved, and it will be done by the chromium ions. It is in the form of a cylindrical rod. The resonant cavity, the second important part in so-called construction, is resonant cavity. Both the ends of the rod are made highly polished and made strictly parallel. The Ruby rod is made highly polished and made strictly parallel. One fully reflecting mirror is connected at one end and a partially reflecting or partially silvered mirror at the other end. Okay, here you can see in this diagram fully reflecting plate at the left end and the partially reflecting plate at the right end. Oh, then exciting system. What is the exciting system? What is responsible for the lasing action? Okay, a xenon flash tube is surrounding the Ruby rod in an helical structure. A xenon flash tube is surrounding this Ruby rod, okay, which provides a pumping light to excite the chromium ions to the excited state. But actually 1000 joules of energy is emitted by the xenon flash tube in few milliseconds, but only few amount of the light is responsible for the pumping action. The remaining amount of energy will be wasted and it is responsible for heating up the system. So in order to cool the system, a cooling arrangement is made or provided to keep the experimental setup at normal or room temperatures. So a cooling system is provided in order to keep the laser at the normal temperatures. This is about the construction. Now coming to the working of the laser, here I can say that I said that Ruby crystal is a 3-level solid state laser. When the crystal is excited, initially the chromium atoms will be present at the ground level. Okay, then by using the xenon flash tube, which will be emitting bluish color or bluish green light when falls on the atoms that are present in the ground state, by using the pumping transition, the atoms that are present in the ground state goes to the excited state by using that light, which will be having an wavelength of 5500 angstroms. By using that light, the chromium atoms that are present in the ground state goes to the excited state E3. Now the atoms that are present in the excited state, the excited chromium ions, will give their part of their energy to the crystal lattice. They will give their energy to the crystal lattice, and the chromium ions will falls back to the energy state E2, which is called as the metastable state. This is the place where the population inversion is achieved. Okay, initially the pumping transition is represented by the 1, and the second transition by which due to the crystal lattice vibrations or collisions, the atoms, chromium atoms will come to the metastable state by emitting no radiation. This transition is represented by 2, and it is termed as the radiationless transition. Now the metastable, this process will goes on continuously, in which the metastable state will be having more number of chromium atoms compared to that of the ground level even atoms. This process, you know that it is called as the population inversion. So the population inversion is achieved in the Ruby laser. As the state of inverted population is unstable, so the chromium ions will comes to the ground state after completing their lifetime by emitting a photon having 6943 Angstroms of wavelength without any external influence. So this transition is represented by the transition 3, and it is termed as the spontaneous emission. It happens without any external influence. Now after this transition 3, this atom or this photon will be traveling in the active medium, hitting the 2 mirrors. While passing through these mirrors, it will hit the atoms that are present in the metastable state. By hitting the atom in the metastable state, as you know that the external influence is this photon, by hitting this atom, it will comes to the ground state by emitting an additional photon. This process is known as the stimulated emission, which is responsible for the laser transition, and it is represented by the transition number 4. Okay, this transition is known as the laser transition, and it will be having a wavelength of 6943 Angstroms. Okay, these atoms will goes on traveling in the active medium continuously and hitting the ends of the rod completely. After a sufficient intense beam of laser is formed, so that it is capable of coming from the partially reflecting end, a laser beam will comes out. This process takes place repeatedly, and when the beam comes out sufficiently intense, and it escapes from the partially reflecting surface. Okay, first transition is called as pumping, second transition is radiusless transition, and the third transition is a spontaneous emission, and the fourth transition is the laser transition or stimulated emission. Now coming to the characteristics of Ruby laser, you can see, as I said, its type is a 3-level solid state. Laser, and the active medium we used is the Ruby rod. The Ruby crystal is used as the active medium, and the pumping method we used is the xenon flash tube light. Xenon light, which is known as the light optical pumping method, is used in this Ruby laser, and the optical resonator is the 2 ends of the rod which are polished or which are made strictly parallel. Okay, it is used as the optical resonator. The output power of the Ruby crystal or the Ruby laser is 10 power 4 to 10 power 6 watt. It is the energy of the Ruby laser. The frequency of output is about the 4.32 into 10 power minus 14 hertz. Okay, this is the frequency of output. And coming to the wavelength, it is 6943 Angstroms, which will be in red color. Okay, which will be in red color, and it will be in visible region. The nature of output is pulsed beam laser. It is one of the drawback that the laser light which is emitted by the Ruby laser, it is a pulsed beam. Okay, these are the characteristics of the Ruby laser. Now coming to the drawbacks. Okay, drawbacks of Ruby laser is the Ruby laser requires an high pumping power. It requires an high pumping power, and the efficiency of Ruby laser is very small compared to that of the other lasers. And as I said, the main drawback, it is a pulsed laser. A pulsed beam is released. It is a pulsed laser. Now coming to the advantages or the merits of the Ruby laser is that it is used in optical photography. The Ruby laser is used in optical photography. The measurement of plasma properties such as electron detect such as the electron you can see here the measurement of plasma properties such as the electron density, or it is used for the removal of melanin from the skin, and the Ruby laser is used for the recording the hologram. The Ruby laser is used for the recording the holograms. These are the advantages of the Ruby laser. So this is about the Ruby laser. As I said, it is belongs to a solid state laser. Goes back to the other laser, which is a gas laser. So helium neon laser. It is a helium neon laser. Coming to the introduction of the helium neon laser, Ruby laser is a 3-level solid state laser, but helium neon laser is a 4-level gas laser. 4-level gas laser. The main drawback of the Ruby laser is a continuous beam laser, but the helium neon laser is a continuous laser out. It will emit a continuous beam of light, continuous beam of laser. Okay, we can achieve high coherence and high directionality and high monochromatic beam by using this helium neon laser. The fabrication is done by the Vijayawada and others. Okay, by using the gas laser, the main advantage is that we can achieve high directionality, high coherence and high monochromatic beam. And as I said that by using a gas laser we can achieve a continuous laser output. Coming to the construction of an helium neon laser, you can see in this diagram, it consists of a discharge tube which is having length of 80 centimeters and a diameter of 1 centimeter. Okay, a diameter of 1 centimeter and a length of about 80 centimeter discharge tube is present. The discharge tube consists of a mixture of helium and neon gases taken in the proportion of about 10:1 ratio. Helium is taken in the 10 ratio and 1 is the ratio belongs to the neon at a pressure of about 1 mm of mercury. Okay, at a pressure of 1 mm of mercury. Mixture of helium and neon gases which will be acting as an active medium is taken in this discharge tube. Now, two mirrors called as the M1 and M2 will be placed at both the ends of the discharge tube. One is highly reflective, while as the other one is the partially reflective. Okay, this is about the construction of the helium neon laser. Coming to the working action or the working principle of helium neon laser, when a discharge tube passes through the gas mixture, when the electron passes to the gas mixture which is of helium and neon atoms, the helium atoms excites to the ground state here, excites from the ground state to the higher energy states E2 and E3. This is done by the phenomena, or this process is called as the pumping, while E2 and the E3 states are called as the metastable states. Okay, E2 and E3 states are called as the metastable states. The excited helium atoms then they collide with the neon atoms and transfer their energy to them. Initially, the atoms that are present in the helium atoms that are present in the ground state absorb your energy in the discharge tube and goes to the energy states E2 and E3. Now they transfer their energy to the neon atoms by atomic collisions, which are the neon atoms that are present in the they will transfer their atoms, the helium atoms will transfer their energy to the neon atoms. Now coming to the neon atoms, the neon atoms can easily jump from the energy states of E5 dash and E4 dash. Here you can see they can easily jump from the energy states E5 dash, E4 dash and E3 dash after colliding with the helium atoms, and they comes back to the ground state. Here the transition that is responsible for the laser transition is E5 and E4 dash are metastable state. Here these two states are metastable states and they have a lifetime of longer lifetime which is about the 10 power minus 3 seconds. than that of the energy level E3 dash. Okay, therefore the population inversion takes place between the energy levels E5 dash and E4 dash and E3 dash. Here the population inversion is achieved when the excited neon atoms from the E5 dash and E4 dash comes to the E3 dash. Okay, the helium atoms transfer the energy to the atoms of the neon atoms, so the atoms will comes to the ground state. So as I said, E4 and E5 dash are metastable state. The E5 and E4 transitions are responsible for the lasing action. Now if the photon is moving, but see here in the E4 and E3 transition will be having a lasing action, but it will be having a minute wavelength. But E5 dash to E3 dash transition is the transition that is responsible for the laser output, that is responsible for the laser beam. Okay, that is responsible for the laser. But as I said, in order to stimulate that atom which is present in the metastable state, the atom that comes from the E3 dash to the E2 dash atom will be emitted by a spontaneous emission. That spontaneous emission atom will hit the atom that is present in the metastable state, and the stimulated emission is possible. Okay, now the atoms that are present in the E2 dash state will comes to the ground state by emitting this transition is represented by the de-excitation state. If the photon is moving parallel to the axis of the tube, it is reflected back and forth by the mirror. Okay, the two mirrors are there, no? The atom, this photon will hit the back and forth motion unless an intense beam of output is emitted. Thus it causes a fresh photon in phase with stimulated photon. This results in high intensity laser beam emitted from the partially silver end. Coming to the characteristics of helium neon laser, the following are the few characteristics of the following are the characteristics of the helium neon laser. Okay, that the type of the helium neon laser is a 4 energy level laser, 3 neon and 1 in helium. Okay, 3 energy level gas laser. The active medium is a mixture of helium and neon gases which are taken in the ratio of 10:1. The pumping method that is responsible for helium neon laser is the electric discharge. The optical resonator, the optical medium used in helium neon laser is a pair of plane mirrors facing each other. The output of this laser is about 0.5 to 50 milliwatt, only 0.5 to 50 milliwatt. Coming to the frequency of output, it is of 4.7 into 10 power 14 hertz of output beam is released. The wavelength of the output is about 6328 Armstrongs. The nature of the output is a continuous beam of light. The nature of output is continuous beam of light. Coming to the advantages of or merits of helium neon laser, the main advantage of helium neon laser is it operates in a continuous wave mode. The Ruby laser is a pulsed wave mode, but helium neon laser is a continuous wave mode. As I said, by using helium neon laser we can achieve more chromatic and directionality, and no cooling is required, and it will be as less expensive compared to that of the Ruby laser. The applications of helium neon laser is that they are used in laboratory experiments to produce interference and diffraction patterns aligning the Ruby laser. Okay, then they are used in the ophthalmology, and they are used to produce the holograms. Helium neon laser are used in producing the holograms. The next topic are the applications of the next topic is about the applications of lasers. Coming to the applications, the first important application, the lasers are used in communication. For communication purpose we use. In case of optical communication, semiconductor laser diodes are used as optical sources, and they will be having a bandwidth of 1014 Hz and is very high compared to that of the radio and microwave communications. That's why laser communication is used. More channels can be sent simultaneously by using this laser source, and the signal cannot be tapped The signal cannot be tapped by using the laser. The next important application is they are used in computers. They are used in barcode scanners. When we go to a mart, we can see a barcode scanner, a laser will comes out and it will read that barcode. And in LAN, local area network, data can be transferred from memory storage to one computer to other computer using laser for short time. Okay, lasers are used in CD-ROMs during recording and reading the data. The next important application, they are used in chemistry. Lasers are used in molecular structure identification. Lasers are also used to accelerate some chemical reactions. In order to accelerate some chemical reactions, the lasers are used. And by using these lasers, new chemical compounds can be created by breaking bonds between atoms and molecules. Okay, these lasers will break the bonds between the atoms and molecules, and they will create a new chemical compound. Okay. The next important application, they are used in photography. You will see in these movies, lasers can be used to get the three-dimensional lens photography. Okay, three-dimensional lens photography, and lasers are also used in construction of holograms. Even in these movies, we will see a hologram is prepared by using these lasers. The next important application is they are used in industries for cutting metals, for designing on a metal. Lasers are used. Lasers can be used to blast holes in diamonds and hard steels. They can be used for blasting the holes that are present in the diamonds. Then they are used to cut the teeth in the saw. And lasers are also used as a source of intense heat. Okay. The next application is they are used in medicine. The pulsed neodymium laser is employed in the treatment of liver cancer. An argon and carbon dioxide laser are used in the treatment of liver and lungs. Different lasers are used to treat different diseases. Different lasers are used in endoscopy to scan the inner parts of the stomach. To scan the inner parts, different lasers are used, and these lasers are also used in elimination of moles and tumors which are developing in the skin tissues. So here you can see in this diagram, the skin tissues used in elimination of moles and tumors. Okay, now coming to the other application in military purposes, lasers are used as a war weapons, and high energy lasers are used to destroy the enemy aircrafts and missiles. Okay, lasers can be used in the detection and ranging like radars. They are used in radars. And the next important application there, it is main, okay, in scientific research. Lasers are used in the field of 3D photography. Lasers are employed to create plasma. Okay, to create the plasma. Lasers are used in Raman spectroscopy to identify the structure of the molecule. Lasers are used in the Michelson-Morley experiment. These are the applications that are using the lasers in different fields, in industry, scientific research, military, whatever the purpose, in different areas lasers are being used. Okay. This is all about the lasers. I'm going to the next topic, holography. What does a hologram? How it can be created? How a Gabor hologram is prepared? Okay. Coming to the holography, the idea of hologram was first proposed by Gabor in 1948. Okay, that's why sometimes it will be called as Gabor hologram. Okay. In Greek, holo means whole. Okay. And the graphy means writing. Complete writing of the image, complete three dimension of the image is known as the hologram. A hologram contains the whole of the information of the wave from the object phase as well as its amplitude also. Okay, complete recording of an image is known as the holography. Okay, a hologram provides a true three-dimensional record of the object. Okay, whatever the object. Okay, it will be used in many movies. Okay, it will be having many applications in future, this holography. The hologram itself is two-dimensional, but using a laser, a three-dimensional image can be constructed. Okay, actually a hologram itself a two-dimensional, but using a laser, a three-dimensional image may be constructed. Okay. Coming to the preparation of a hologram, here you can see a laser beam is divided into two parts. One is called as the reference beam, which will be directed towards the photographic plate. After reflection of a lens, a curved mirror Okay, the second beam will goes to the object, illuminates the three-dimensional object. They will meet on the photographic plate. Okay, first one is called as the reference beam and the second one is called as the laser beam from the source. The reflected or the scattered beam falls on the same photographic plate. Both the two beams will meet at the photographic plate. The two beams are derived from the same source, hence they are responsible to constitute the interference. They are two coherent sources. Okay, the resulting specific interference pattern is recorded on the photographic plate, which is a hologram, and contains all the information or all the intensity, all the amplitude and the phase required to produce the wavefront of the object. Coming to the reproduction of a hologram, the hologram is illuminated from a. Coming to the reproduction of a hologram, the hologram is illuminated from a single beam from the laser. Okay, it will be illuminated by single laser beam. Okay, the hologram acts as a grating and the diffraction pattern recreates precisely the wavefront emanating from the original object. It will be emanating from the original object. But in addition to the virtual image, a real image is also formed. The real image can be photographed without the aid of the lens. The real photographed image will be formed. Now coming to the applications where the holography or the holograms are used means, in future it will be used in many areas. I think in future in the medical field it will be a big advantage in order to identify this where the patient is having problems. This one will becoming an important thing in this future. The image formed by sound due to holography is used to view the image of an object in water. Okay, in water as well. Okay. An ultrasound generator is used to emit the reference signal, while another ultrasound generator emits signal in the direction of underwater object. Okay. Underwater object as well. The ripples are generated on the calm surface of water, which serves as a hologram and can be photographed. Okay, it can be used in in order to view the internal parts of a patient. It will be used in different areas. Okay, that's why this holography will become a main advantage in this future. Okay, with this session we will concluding the entire course wave optics. Thank you for listening.